So very good morning to all on the very last and the fifth day of this GAN course on climate change and compound hydrometeorological events, insights from data and modeling from 19 to 23rd May. ये लेना since you requested for the bias correction and all, so we will go with that, and then finally we will come for the drought competition. So if we talk about bias correction, I have discussed you that there are some bias correction techniques like distribution or quantile mapping or probability distribution mapping. So these are फिर we can say linear scaling of precipitation or temperature, or we can say variance scaling of temperature. So there are different techniques which can be done, which can be used for the bias correction. So for that, if you need the very simplest solution for bias correction, you can go ahead with the CM hide. So I will let you know how we can do using the bias correction. We can do bias correction using the CM hide. I think anyone you have any .nc file for any GCM, so that you can perform also, you can share in the group so that everyone can do that. Otherwise, for the CM hide, you need not to have any other data sets with you right now. Whatever the data set is available in the CM hide for the as an example data set, you can use with the, you can go with ahead that. So I will share, like this is the CM hide. Once you type on the Google that CM hide, you will get this website. So initially you have to go for the very first link. So in this you will have three files to the download. The first one is CM hide installer, the second one is CM hide user manual, and the third one is CM hide example data. So all three data set you can download. User manual you can go ahead so that you can have an idea that how you can perform. Otherwise, if you want to perform directly, you can download the data that is CM hide example data. So there is historical data as well in this, and the files which we need to prepare as a text file for the CM hide also, there is example for that. So initially we will go with the CM hide installer. So you just need to download the very first file. You can do, I think, along with me, so that you have a better idea that how you can perform this. Means this is the simplest way you can do the bias correction without any coding, without anything. You just need to know what are your lat, longitude and the elevation of the point. That's it. Other than that, whatever the data, for example, if you want to do the bias correction for the precipitation, so for the raw period, or we can say the historical period, you have the IMD observed data, that is precipitation or temperature data, and you must have the future data. Future data you need not to have in the Excel file. Whatever the data set you are picking from the GCM, that is NC file, you take that NC file directly. No need to convert that NC file to any other format itself. So let's go with this installation. I think I have to share that link to the group so that everyone will get it. Yeah. So this is a CM hide installer. example data which is required in this. So just download that. So it's done. So initially whenever you click on the CM hide desktop icon, initially this will come. So yes, once after this black screen, this will come to your screen. So this is the platform where you have to do that. I think in this you can see the processing and the plot part. So there are two works carried out by this CM hide. First one is the processing, in which it will do the bias correction, and the second one is the plotting, where whatever the data sets you have, either you have corrected the historical one using the observed IMD data set, or whatever the future bias corrected data set, you can plot here itself without using any Excel or anything other software for the plotting. The second important thing, since in the processing itself you have to select the variable here itself. So before going into this thing, we have to prepare the files. We have to prepare the download data which is required for that. So let's go for that. I think it's already okay, it is in process, but I think I have shared in the group also, so you can open that. In that you have one file, text file as PCP or PEMP. So you can name anything, but since all the names in the user manuals are like that, so I have kept that file name as like PCP or PEMP. So the PCP file which you have prepared, which you need to prepare in the text format, is consist of 5 parameters that you have to do. I'll show in the user manual also. Okay, this is the user manual. You can go ahead with this, and initially you have to create the file which is required at the location climate data ASCII format, that is a location file, and in this file we have to use these 5 things, that is the ID. You can give any ID like 1, 2, 3, 4 for your identification, so that you have a number of that. Then the name, so name, for example, you have 10 grid points or 10 location like Bhopal, Indore, everything. So what you can do, you can write a name for Bhopal, then you can write the name for Indore, Satna, Jabalpur, anything like Delhi, then let of that particular place, longitude of that particular place, and the elevation. So you have to prepare this for one location. If you have several, you can make 10, you can give the detail for 10 points, 12, 20 points, 1000 points, whatever the points you need to give, you can give here, and then you have to go for the next format. Next format is the data file, which is for the temperature or precipitation. Because for example, if you have given the ID that is 1, name is like Bhopal, and you have given the lat, long and elevation. So initially with the help of this Bhopal file, we have to prepare the Bhopal file also for the precipitation or temperature. So in this case you have to prepare this file. You have given this file name as a Bhopal and you have put here, but then you have to prepare this Bhopal file. So in Bhopal file, what you have to do, you have to start with the date. So I think data is already downloaded. We will show with the example so that you will get better idea about that. Okay, this is the example data, or this is the observed one, this is the precipitation. So this is the example. Initially we need to make this file. For example, we have 4 points where we have to do the bias correction, like the first one is Bhopal, second is Indore, third one is Chennai, fourth one is Delhi. So these are the ID names. Then the name of that file. For example, if you put Bhopal data in the first file, that is P53997. Second one is P539100 for Indore. So you have to give the name and then the lat of that particular city or a particular study area, then longitude and then elevation. So this is the very first file you need to make. Then correspondingly you need all these files, that is P5, 9100 or 9103. So we have to prepare that. So these looks like that. So how it does, how we need to give the data set? We need to give, initially we have to give the year, then we have to give the month, and then we have to give the date. So it is like year, then the month, and then the date. These are the three things you have to give, because the software needs the exact date from which you are giving the data set. For example, you have the data set from 1st January 2000, so you will give the data set from 200101. If you have more than 20 years, 30 years, you can give anything. So initially you are giving, for example, if you have data set from 2020 itself, 2000 itself, so right now for this you are giving the data set for around 25 years, so 24 years till to 31st December of 2024. So you have to prepare the file for different areas or the grid points you have. So you okay, yeah, this text file is there. You just need to write the date, means mostly we have the data set in Excel file. So you just copy the Excel file data set, initially open the text file, write the initial date with the month and year, but the condition is that you should start with the year like 2000, then you start with the month, that is 01 like for January, and then you have to start with the date, for example it's 1st January. Then whatever the data set you have for 20 years or 24 years, you just copy it or paste it here in the text file and name it as anything you want. For example, you can write P1, P2, P3, and similarly you have to write that name here, 1, P1, lat, longitude, and please put these comma also, otherwise it will not, it will show error. Means you can do one thing, you can keep this example data file and you can just alter the file, modify the files according to your needs. Don't create the new ones. Once it's done, then you need the NC files for that. Then I think in the example, if it is there, we will use that. Yeah, NC file is there in this. Okay, so this is like precipitation or temperature data set we have, and for precipitation itself we have NC file here. So these are some of the NC files. They may be of the observed period, they may be of future period. Then we have to come directly with this, where we need to do this. So initially what we do, for example, if we want to do the correction for precipitation, you just need to click on the precipitation, then you have to select the location file. Okay, so for example, you selected the variable precipitation or temperature. I think why it is not for doing for precipitation, I have no idea right now, but I think yeah, it is also running for precipitation. So if it is not working, you just click on the second variable and then it will start working for the first variable too. So then you have to select the location file. Which file? Initially we have created the PCP file which have the data set for everything. Means you have to go for that PCP file. I'll show you. This is the desktop, and okay, download, then example data, and then observed, and this is the precipitation. So this PCP file you have to upload here. Then there are different methods which can be used for bias corrections. So usually there is some method like linear scaling. So linear scaling can also be done for precipitation and temperature both. Like variance scaling can be done, but variance scaling is useful only for temperature, not for precipitation. So how you get to know that which one is useful for precipitation and temperature both, which one is not useful for a particular data set? Is there any classification based on that we can use the bias correction method for particular variable? Any idea? The thing means, for example, we have a lot of bias correction techniques. So how we justify that this one can be used for both variables like precipitation, temperature, or any other variable, or this can't be used for this particular variable to correct the data set. So the thing is, it is based on the distribution. So you have idea about gamma distribution, Gaussian distribution and all. So if you correct these, some of the bias correction techniques are using only the gamma distribution. They are fitting the data into the gamma distribution only. So gamma distribution is only used for positive values, means like from 0 to positive value only. So if you put a gamma distribution for the precipitation, is it valid for it? Yes, because precipitation can't be negative. For example, if some bias correction technique is fitting the data into the gamma distribution only, then that distribution or that technique can be used for temperature. Yes or no? Yes? How many say yes? For example, a bias correction technique is using Gaussian gamma distribution for the correction or fitting the data set. There is a technique, for example, X technique, to do the bias correction, in which all the data set is fitting into the gamma distribution, and then it is doing the bias correction. And gamma distribution have a property that it will have a value from 0 to positive values only. It means the positive one. So we are fitting the precipitation. For that we can do that. For that bias correction technique can be used for a bias correction of precipitation data. What if we will use for the temperature also? Because temperature can also have negative value. So if you are going to bias correct that data set, it may correct the data set, but it will not correct exactly. It will do the wrong correction, because I think what it will do, it will treat all the negative value also as positive. Yes, if doesn't have negative value, then because this distribution have no relation with the temperature or precipitation value, it have relationship with positive or negative value. It doesn't care about whether it is temperature or like soil moisture data or anything. It needs only positive value to do that, because what initially gamma distribution is doing nothing. It is fitting the value, all the value into a distribution. That's it. After that, bias correction will take place. So if you are going for precipitation along with the temperature, means you want to fit only a same distribution, then you can't fit gamma. You have to go for Gaussian distribution. Gaussian distribution have negative, 0 and positive value. So like quantile mapping you say, or we can say distribution mapping. These are the same. Quantile mapping or distribution mapping are the same. They are only having different names, like quantile mapping, probability distribution mapping, or probability mapping, or we can say statistical downscaling. These are same. They are based on historical data sets. That's why in statistical, what we are saying, whatever the trend in the observed period, the same will be carry forward to the future. That's why we know that this is not possible practically, that whatever happens in the past, we are treating the same thing or carry forwarding that same thing to the future, but it is not practically possible. In this, we are considering one assumption, I think you know, that is stationarity. And stationarity doesn't exist. That's why we have another topic, that is non-stationarity, because stationarity is not existing, because whatever the climate we have in the last 30 years, we can't say that the same will happen in the next coming 70 years or 75 years. So here I will not go into deep, otherwise we will not able to do this. So distribution mapping we will do, because it use both distribution, that is Gaussian and gamma. So it will fit all the data set, the precipitation plus temperature, or precipitation into Gaussian, gamma, and temperature into the Gaussian distribution. So we will do here. Then we have to select the net CDF file. So we will select the net CDF file from here itself. So this, for example, precipitation. Okay, so in this folder itself, I think we have net CDF file. I think in this example files it is not showing, that's why in the morning itself I asked about the LC file if you have. Yeah, okay. So in this, then you have to select for which scenario you are correcting the data set. For example, 4.5. In this it have only 4.5, and I think it is showing the file name also. Only one file, any one of the file, means in which you have to do the correction. I think you can see the time period is also showing, that is from 1996 to 2005. Since this is an example, means given by the CM Hyde. Here, if we are doing the bias correction, we will get the data from 1970 to 2005, or we can have the data set, I think, because this is for RCP. So for example, if this NC file have the data from 1970 to 2005 or 2015 itself, so we will give the same data set here itself. Okay, so here we will give the input file, and whatever the time period the historical NC file have, the same data set we will give in the that precipitation text file, that P1, P2, P3, P4, because there should be overlapping period time. So after that we have to select the folder in which bias corrected file will be saved. So we will select any folder in which we can save the output file, and for example let's do that here, like output file. So you write output, select this one, then importantly check all the files that there is no issue with the files, and once you click on the check files, then only these two buttons will get enabled, that is this and this. This is very important because it is establishing the relationship between the observed period which is given by the IMP and the observed period for the climate model itself. For example, your model is giving from 1970 to 2005, so you have to give your data set from 1970 to 2005 itself. Then this is the overlapping period. So please click on this so that it will establish a relationship. Here itself means right now it is showing Cordex. This is an example only. You can download 10 GCMs. You have to go one by one. Initially, for example, you have Cordex, then you may have C and RM GCM. Then you can go for the I think MPI, ESM, LR. There are different GCMs. Right now we have CMIP 6, so you can download 10 or 15 out of them. Then initially you have to go folder one by one. Initially you have to go for the first GCM, then you have to go for RC, SSP first, second, third, fourth, like this. Okay, yes, because IMD data set for 1970 to 2015 is same for everyone. Means like as a 5 participants have modeled 5, given 5 GCM models. Okay, so you have taken something as a different thing. She has taken some different assumptions to create the models. He has taken something different assumptions to create the GCM models. So what we do at the end, that all three have declared this is the data set of precipitation from 1970 to 2015 by using different assumptions. But for all of you, the reference file is IMD only. So you will take 1970 to 2015 IMD data set. That is same for you. So that is here. Then you just start processing it. Once you process, the file which you get into the output format will be in bias corrected file. So this is the way to correct it, and I think we can see here. I think in the output we have PCP file, and this is the row and this is the distribution mapping, and you can see the file which is corrected here. For example, these are different files, so we will open one by one. These are output files. So whatever the input, if since you have given 5 input files, you will get 5 output files for that particular scenario of that particular GCM. So you can do this using some of the data sets. So I request you, if you have any GCM file with you, like NC file for any GCM, you can just proceed with any of your study area for like a grid point, one grid point between the break 11 to 11:30. So in that period, if you don't have any doubt for that, you can ask. Okay. So this is the bias correction, and in this, sometime you do one thing, that there are different ways to do the correction. So you can go with the minimum 2 bias correction technique, so that you can compare that which one is better. As far as I concerned, I have done the quantile, or we can say the distribution mapping, and results are very good in terms of precipitation or temperature data set across Sikkim itself. So because the reason behind the distribution mapping is only one, that it fits the precipitation into the gamma and temperature into the Gaussian distribution. So this is all about this. Then since we have to carry out the lecture also as per the GAN guidelines, so we will go further with this. And if you need the code for drought, so we can also perform that also. Means we can compute SPI, SRI, SSI and VCI in this class itself after just the break. So that I'll share the code for SPI, SRI, SSI and VCI. You just put the input variables, and I'll share the input files also for particular region itself for 1 or 2 grid points. Then whatever the study area you have, you just use Excel file instead of that and just run the code. You will get the SPI, SRI, SSI and VCI for all the study area. So in this, initially we will discuss what is the reason behind to carry out this study, and then what are the input data sets, and what are the code we have used in this study, and what are the input files we have. So in this we will discuss the occurrence, concurrence and evolution of meteorological drought across Indian river basins. So I think you know about the occurrence or distribution. That is very common word. What do you mean by concurrence? Any idea about concurrence? Repetition. 2 or more events occurring together. For example, here the concurrence means 2 or more than 2 types of drought, not the same drought type. Concurrence means, here in this study, concurrence means if meteorological drought is occurring with hydrological drought, that is the concurrence part. Most of the study we found that usually people find out the occurrence and distribution and the trend of any of the drought like meteorological or hydrological, but we can't say that only if meteorological drought is occurring, it is occurring continuously. No, sometime just after the meteorological, hydrological is occurring, means meteorological plus hydrological drought is occurring simultaneously at the same time. sometime hydrological plus agricultural drought is occurring at the same time. So that thing is known as concurrence. Second important thing, sometime a particular drought like meteorological is converting into another drought type, like meteorological is converting into agricultural drought. That is known as a drought evolution. So there are three important things whenever you are computing the drought. The first one is the occurrence or distribution of the drought. The second one is the concurrence, where more than two types of drought. It can be 2, it can be 3, it can be 4. When they are occurring simultaneously at the same time, and when one particular drought is converting into another drought type, that is known as drought evolution process. So in this study we have calculated meteorological, hydrological and agricultural drought. However, agricultural drought we have further subclassified into two types, that is known as soil moisture drought and vegetation drought. So let's discuss. So I already told that drought is further, agricultural drought is further classified into two types, that is soil moisture and vegetation, so that we can define the agricultural drought based on soil moisture and based on vegetation condition also. In this study we have not identified only the severe drought conditions or what is the spatial extent of individual droughts, but also we have done the concurrence of that, and finally we have also evaluated the evolutionary process among these four types of drought in this study. So this is simple description why we need to think about the drought, how these different drought types are occurring. So if we know about the climate change, so due to climate change we have climatic variability, or we have some alteration in our climatic variables. Due to that alteration, sometimes we have less precipitation, or it results into the no precipitation condition, or sometimes it leads to the high temperature, low humidity or high sunshine hours. So this lack of precipitation or precipitation deficiency itself leads to the meteorological drought. Similarly, due to this variability in the climatic variables, it will cause soil moisture deficiency, and this soil moisture deficiency will result in the agricultural drought. And finally, if we talk about the stream flow deficiency, it means whatever the average level of the water body is, if it is fall below the average level, then it is resulted into the hydrological drought. So this study has been carried out all across India in 25 river basins as per India Varis 2014 classification, like I have denoted by the numbers like 1, 2, 3, 4 and 24. So initially one is showing the Indus, then Ganga, Brahmaputra, Barak, Godavari, Krishna, Kaveri, Subarnekha, Brahmani and Batarni, Mahanadi, Penal, Mahi, Sabarmati and all. Then these are some of the data sets we have used, since this is an old study during my PhD itself. So the data set is up to 2013 only, but we can right now it is available till 2025 for 24, we can go ahead with that. So the thing is that for precipitation itself, initially in this study we have taken at 0.5 degree, but you can take at 0.25 degree itself, because we have precipitation at 0.25 degree from India Meteorological Department. This is my spelling mistake, please. So this is India, not Indian Meteorological Department. So this is IMD. Second, runoff and soil moisture is taken from MERA 2, that is modern era retrospective analysis for research and application. So if you are using soil moisture or runoff, you can go ahead with the MERA 2 data set. It is reliable, and we have published more than 3 papers using the MERA 2 data set for in terms of soil moisture or in terms of runoff. So if you want, you can go ahead with the MERA 2 data set, since it has different resolution. Along with that, for vegetation drought we have used NDVI, that is taken from GIMMS, that is Global Inventory Modeling and Mapping Studies. So that is also you can take, that is available at 1 by 12 degree into 1 by 12 degree. So all we have regraded into 0.5, but right now if you are doing at present time, please I suggest you should regrade into 0.25 degree, because this data set is available at 0.25 degree itself. At that time we have taken a 0.5 degree. Then the methodology of the study. So initially you have to take the data set like precipitation from IMD, runoff and soil moisture from MERA 2, then NDVI from GIMMS. Based on that you have to calculate the drought indices like SPI for using the precipitation as input, runoff. Using runoff you have to calculate SRI, SSI using soil moisture and VCI using NDVI as a input data sets. Once you've done this, then you have to characterize the drought. So based on SPI you can characterize the meteorological, based on SRI you can characterize the hydrological, then based on SSI you can go ahead with the soil moisture, and finally with the help of VCI you can go for the vegetation drought. Once you're done with this, then you can go for the other sub-objective of this study. So you can find out the spatial and temporal extent of the drought conditions, then you can find out the drought trend. So in this we have not used any drought trend method, like you have heard about the MK test, man-candle trend analysis test. We have not used any test to find out the trend, we just show the trend based on the decadal basis. So in this trend we have shown how the spatial extent of drought is changing on a decadal basis from 1980 to 1990, 1990 to 2000, 2000 to 2010, like that. Then we have shown the frequency, how frequency is changing across the decades, and then finally we have shown the third thing is that is the the severity, and finally we have calculated the drought concurrence means how two or more than two droughts occurring at the same time at the same study area. For example, if we talk about 1980, that how the drought are occurring in the Bhopal, two or more than two droughts are occurring in the same time in the same study area itself. And finally we have shown how the drought is evaluating from one place to another place itself. So like for example, meteorological is converting into hydrological, so this is the drought evolution process itself. So these are the classification based on the severity itself. We have used this because this classification is common for SPI, SRI and SSI. It is not worldwide famous. Some of the study says that if SPI value is just below 0, just like negative only, just below the 0 itself, it shows the drought condition. But here we have not used, we have considered this thing as a drought. Before that it is declared as abnormally dry, not the drought condition. This is declared by this paper in 2002, that if you have the SPI value below 0.8, minus 0.8, then only we can declare the drought, otherwise it's a dry condition. So these are the three common classification for SPI, SRI and SSI, and for VCI itself this is the condition. So based on that we can say we have moderate drought, severe drought, extreme drought or exceptional drought itself. So these are some of the results on the temporal extent, where we have seen what is the temporal extent of the drought across India. Then in this we found that April to July are usually judged as the most drought prone months, when all four kinds of drought usually occurs at the same time, means all the four droughts are occurring in these months specifically. So we can say these are more drought prone months, that is April to July itself. Then we have find out the result of drought trend, in which initially we show the mean duration, that how the duration is changing across the decadal basis. And we found that meteorological droughts remain slightly longer since 1982, that is increasing from some period from 2.16 to 2.32 months every year. However, other three are showing some decreasing pattern. Similarly, we go with the mean areal extent, means the spatial extent across all three decades, and we found that meteorological drought also having mean areal extent which is increasing from 1980 to 2013 itself. Then the same we have done for the frequency, and results are similar, that meteorological drought is showing the increasing trend across these three decades. So we can say that meteorological drought occur more frequently with more mean duration and higher areal extent. Then this is the drought concurrence, where we find out for, I have shown this figure only for particular river basin. We can show for other river basins also. So for example, in 1984 itself, we can see in the May we have three drought types, that is meteorological plus hydrological plus soil moisture droughts. So in total, if we talk about this particular river basin, we found 31 concurrent drought events in last 20 years from 1980 to 2013, out of which April to July were identified as the multi-drought prone months with over more than 54% of this. You can see that majority of the concurrent events are occurring in these 4 months. That's why they are also known as drought prone months. Majorly, out of that you can see one thing, that most of the cases we have only two combinations. Most of the cases you can see. Some of the cases have 2, 3 or 4 combination. I think only where we can find out the one combination that is having all 4, otherwise majority having 2 combination. So we can say 2 drought based conjunctions are account for more than 70% or 71% of concurrence drought types, out of which 84 concurrent droughts included the soil moisture drought. Majority you can see that soil moisture drought is more consistent in all. So similarly I have shown here in the spatial extent form where we have shown the concurrence of the drought, and you can see that majority, that the April, May, June and July are having the most of the concurrent droughts, out of which the most important combination we are getting is hydrological plus vegetation, hydrological plus soil moisture and soil moisture plus vegetation. And based on this thing we can say one thing, that India is highly vulnerable to the agriculture drought. How? Because this is a type of agriculture drought. This is also a type of agricultural drought, and both are also a type of agricultural drought. So India is highly vulnerable to the agricultural drought in all the months itself. Then we have shown the results for the drought evolution process. So in this we have not done a lot of work for the evolution. We have very simple classification here. We have done whatever the SPI, SRI, SSI and VCI value we have find out the R square value. Means we just compare 2 drought indices at the same time like SPI and SRI, and then we have plotted its R square value. Then we have SPI versus SSI, then SPI versus VCI, SRI versus SSI and SSI versus VCI. All 4 drought indices we have compared the R square value, and you will find one important thing, that in which color is having the highest value. Out of 5 color, which color is having the highest value every single time for all the river basins? SRI versus SSI. This one black color, that is runoff versus soil moisture. So this suggests that this runoff is also related with soil moisture. So 50% of soil moisture deficit can be explained by the runoff deficit. If we have runoff deficit, we also have soil moisture deficit. So this is the relation. So based on that we can say, if we have this type of drought, we must have this plus this type of drought. It should indicate that only. If we have SRI drought, means the runoff drought, or we can say hydrological drought, we must have hydrological plus soil moisture drought because of this relation. But when we found the result, we found that occurrence of hydrological drought is about 73% more than the hydrological plus soil moisture. It means hydrological drought is occurring, but due to that deficit we don't have soil moisture drought. Why it is so? Because we have the issue with the hydrological drought, but we are not allow agriculture drought to occur because of the irrigation. Because we have the deficit of soil moisture due to runoff also, but since we are compensating with the irrigation process, that's why this value is not equal to this. However, it is more than 73%, and the reason is that we are doing the irrigation at very high rate. If we talk about very old data itself, at that time Indo-Gangetic Plain is having more than 40% of irrigation rate during 2009 to 10 as per the government data platform India. So if we are not doing the irrigation, this should be equal to this, but it is not equal to this because of irrigation practice we carry out across India itself. Then we will go for the second important thing, that is results for the drought evolution. So in the drought evolution itself, you can calculate also the another thing to find out the drought evolution, and that is known as the time lag. Time lag means if one particular drought is occur, then the second drought will occur in which month. After, if we find out the value and it is coming out 1, then it will indicate that 1 month is required to evaluation of drought from one type to another. So we have calculated this. If this time lag is very less, it means evolution is very fast, and if time lag is more, it means drought evolution process takes a long time. So in this we found we have no time lag between these 3-4 kinds of drought. It means we can say this drought evolution can take place in India typically within a month, within 1 month itself. So if it is transforming within the 1 month itself, then what the solution we can have? We must go for weekly studies or bi-weekly studies, because this studies has been carried out on monthly basis. So you can go ahead with the weekly or bi-weekly studies, so that you can find out the time lag between one drought to another. Maybe it's 7 days, maybe 10 days, or maybe 15 days or more. So this is all about this. Then we will go for the conclusion part. So in this we found that hydrological and soil moisture drought are usually more severe than the meteorological and vegetation drought in most of the basins. 2 drought based conjunctions, because we talk about the concurrence, so 2 drought based conjunctions are more than 70% of concurrent droughts. It means mostly we are having concurrence of 2 or more than 2. Then third, April, May, June, July are identified as multi drought prone months across India. Combination like hydrological plus vegetation, hydrological plus soil moisture, or soil moisture plus vegetation are the most observed drought combination as compared to others. And the evolution process of drought of different types are typically takes place within a 1 month itself. So we must go for weekly studies or bi-weekly studies, so that we can have better idea for the drought transformation, that how it is happening across different days. So this is all about univariate analysis of drought. But can you suggest that if we are going for univariate analysis of drought, is it give the better picture about the drought condition or drought characteristics? Because drought is a very complex phenomenon. So if you are finding out like drought duration, or if you are finding out the drought severity, carrying out the study for a univariate analysis, like separately you are finding out the drought duration, then separate you are finding out the severity, will not help you to find out the exact picture of drought duration characteristics, because they are interrelated with each other. You are suggesting something based on the drought duration, you are suggesting something based on drought severity, but can you say that these two things are separate from each other? Drought duration and drought severity are interrelated, or they are separate? They are interrelated. But in this study what we have done, we have calculated the separate analysis. We have calculated using the univariate analysis. So we have to go for the multivariate, or we can say for initially we can go for bivariate, then further we can go for multivariate, like trivariate or like. Yes, for example, if you are calculating the drought duration and severity, you can find out the joint combination or joint distribution or joint probability of duration plus severity. If this is the duration and this is the severity, what will be the case? If duration is less, severity is high, what will be the case? If severity is less, duration will be more, what will be the case? If both are very high, then what will be the case? So this distribution or this probability distribution we must know. So initially we can go for univariate, then we have to go for multivariate. In the multivariate we have lot of options to go for the multivariate distribution, but there are lot of disadvantages in the multivariate distribution. There are different techniques, yes. How we can define the severity? Yes, in the next slide itself I will show that what is duration, how we can compute the duration, how we can calculate the severity. So with the help of figure I will show. So there are a lot of multivariate distribution, multivariate way in which you can do this instead of univariate. But the thing with the problem is there with the multivariate is that most of the multivariate distribution have one assumption, that if you are having two variables and you are fitting them, both of the variable must have same distribution. This is the problem with the multivariate techniques. That for example, you have duration, you have severity, and you are fitting into multivariate distribution, then the condition is that duration and severity both must have either normal distribution or both have log normal distribution, Weibull distribution, gamma distribution, Gaussian distribution, but they must have same. And it is practically impossible that duration may have normal distribution or severity may have log normal, vipul, gamma, any other distribution. So to remove this limitation of multivariate distribution, copula come into the existence. Copula help in this. Copula doesn't have the assumptions that this and this must have same distribution. No. If you have a 3 variable, all 3 can have different distribution. If you have 4, all 4 may have different distribution. So this is the role of copula. Then we need to carry out the study.